All right, when we talk about pressure, all we're talking about is the weight of the air on top of your head. So you can think of it like a big hat, and you have the air, and the air itself has a weight, and that weight is the pressure. Which means that if you have less air on top of your head, there's less pressure. So if you're up high, you have less of a hat, there's less pressure. In addition to just being high and kind of losing kind of this amount of air, it also turns out that there's more air near the surface and less air as you get farther up. And because of that, the pressure is a lot lower at various altitudes. The basic rule is if you go up 5.5 kilometers, you drop the amount of air by 1/2. So this is so we can do it like the following. We start off with sea level, and we can examine several different levels, say 5.5 kilometers, 11 kilometers, 16.5 kilometers, and so on. The air above you, if you're at sea level, there's 100% of the air above you. And there's a certain amount of air below you, but that's not going to be really all that relevant. It'll just be 100 minus what you have above you. So if I go up to 5.5 kilometers, it drops by 1/2. So 50% of the air is now above me. That would also mean that the pressure is dropped by 1/2. And is 1/2 of whatever it is at the surface. If I go up another 5.5 kilometers, it drops by another factor of 2, so it's a factor of 1/2. I have 25% of the air above me, and 75% is below me. If I go up again, this will be 12.5%. Percent of the air is above me, and so essentially the pressure is dropping as I go up, and that is the pattern. Now we may not always have a nice, easy, divisible by 5.5 kilometers height. So how do we do it? The general equation then is the following. We have the pressure is equal to 1,000 millibar, which is the pressure at sea level. Now, of course, this is approximate. The pressure does vary between about 950 and about 1050. And we multiply this by 2 to the negative height that we're at over 5.5 kilometers. Notice that, for example, if I wanted to do 5.5 kilometers. So I would have a pressure of 1,000 millibar times 2 to the negative 5.5 kilometers over 5.5 kilometers. This is 1,000 millibar times 2 to the negative 1, or 1,000 millibar divided by 2, which is 500 millibar. So it's half. At the surface, it's just 1,000 millibar. The height is 0. Anything to the 0 is 1, so we just get 1,000 millibar. So we have the pressure at 1,000 millibar at the surface, 500 at 5.5 K, 250 millibar at 11 kilometers, and so on. But we could also do, what would it be at 1 kilometer? And at 1 kilometer, all I would do is 1,000 millibar times 2 to the negative 1 kilometer over 5.5 kilometers. And it will, without doing the actual numbers out, it'll be somewhere around probably about 900 or so millibar.